on any platform, it might be Facebook or YouTube, right? Share this video on any platform. So it's on PowerPoint. Yes, this is physics, okay? Yes, this is the slideshow that I want us to look at. Put my phone on portrait. Okay, it is. So it's physics date. I changed, but it is at right? It is at 8. So I should just want to tell you, because there was a disappointment. My stylus pen had a problem. I had to buy another one today, right? I had to buy another stylus pen today. And then I managed to do it. And then I started by sending you these notes. These notes, guys, are very, very important. You understand these notes, and then you will see that everything here that you're going to do is going to be very easy. This is the first question. I took it from the trial. I forgot the year and the province, but I think it was last year, but I cannot really remember the province. But this was a trial examination, right? Okay. So they're saying a toy train of mass 2 kg and a toy car of kg are attached by a light axis. What's that, guys? You need to mute your mic before you join the class so that your mic is muted. Make sure that your mic is muted before you even join the class. You make sure that your mic is muted. Okay, so there we are. And then now we've got this one. They're saying a toy train of mass 2 kg and a toy car of mass 1 kg are attached by a light inextensible string. The car train system is pulled up a rough incline at a constant velocity by the rope with a force of T2 with a force of T2 acting on a rope at a 10 degrees angle to the inclined plane. And then they're saying explain the term net force of a resultant force. I'm not going to explain any terms, guys. The terms you'll find them here on the notes, because I don't want to give you something that maybe your teacher will not be comfortable with, right? I'd rather give you the terms if you're going for final examinations, right? But with trial, just keep on using the terms that you were given with your teacher. I'm sure it will also apply on the final examination, right? And then now they are saying draw a free body diagram for the toy train, or draw a labeled free body diagram for the toy train. Okay, so the toy train is this one. Let me have my pen writing. Yes, the toy train is this one. So we need to draw a free body diagram of that toy train. To draw a free body diagram, start by a dot, and then all the forces will be away from that dot, right? Everything should be away. There is no vector that should go into the starting point, right? Every vector should be away. Like for an example, if there was a force coming this direction, you are not allowed to write it in that direction. You write it here, you put it away, right? You write it on the opposite side and show that it is away, right? Make sure that you understand that, right? Okay, so let's go and write our forces. Let me use a black. Okay, so a free body diagram, I'll start by a dot, and then the forces that I have, I've got this T2 here going this direction. So T2 is on some direction there. There is our T2. And then I've got T1 down the incline there. So there is my T1. And then I've got friction down the incline again. So it's FK. And then make sure that every time when you're class, you make sure that the first thing that you have to do is to make sure that you are muted, right? That's the first thing. Even before you join the class, every time when there's a meeting, when you are joining a meeting, you look at your video that is off and your mic is off. That's a very big experience, right? There's a lot of people who have done very lot of bad things, right? You might even get arrested by that. Someone might say something that is very bad, or you might show us something that is very bad, right? Or we might trend by showing us something that we're not supposed to see. You make sure every time you go into the meeting, your mic is muted and your video is off, right? You can set that to be always be like that for every meeting that you're going to attend, right? Okay. So after that, those are the two forces that we have, because they said a rough the train system pulled up a rough slope. Rough slope means that we have got kinetic friction, right? And then the normal force will be perpendicular to the surface. So it's going to be the normal force there, and then the weight will always be perpendicular to the ground. So there is the weight, right? So there is our free body diagram. And then when they come and mark this free body diagram, this is how they're going to do it. It's going to be 1 mark here, 1 mark there, 1 mark there, 1 mark there, 1 mark there. So that is why it have got 5 marks, right? That is why it have got 5 marks. So the alternate free body diagram, this one is the one that we are usually going to use for calculations, right? So when we've got this one here, we use only the horizontal and vertical component. So this T2 here, I've got 2 component, right? I've got 2 component, so we can use them as the, okay, let me start with the normal force, because the normal force, we cannot use any other component. But the weight here also, I've got 2 components. I've got a horizontal component and a vertical component. So we can use this one as what? Can draw a line here, sorry, and draw a line there and show that it's a weight perpendicular, right? Weight perpendicular. You can say it's a weight perpendicular, weight perpendicular, or FG perpendicular, right? And then the other component will be FG, or weight parallel, right? Because I'm using weight, let me keep on using weight parallel. Say this one is weight parallel, right? And then we've got our kinetic friction will remain there, and then the third one will be our tension one, will also go this direction, right? And then with this other force that is T2, it have got 2 component also. You can see T perpendicular, and one will be parallel. So we can use its horizontal component. One is very important because this is the free body that we're going to use for calculations. Although I prefer you to have this one so that you don't lose marks, because here you might make mistakes, but this is the one that we're going to use for calculations, right? The second one is the one that is very suitable to do calculations with, right? Okay, so let's look at the first question. Let's look at 2.3. 2.3, they're saying the tension force for T2 is increased to 20 newtons. It was what? It was T2 acting on the rope at an angle of incline, this one. Okay? A trolley of 2 kg car, 1 kg mass, attached by a lightning extensible string. The car train system pulled up the raft at constant velocity. Okay, there was the constant velocity here. So what does constant velocity mean? Constant velocity, it means that net force equal to 0. Why is net force equal to 0? Constant velocity means that we don't have acceleration. Remember, acceleration is the change in velocity over change in time. So if change in velocity is constant, if it's constant, it means that final velocity minus initial velocity equals to 0, because the final velocity and initial velocity is equal. That is why we always say if we've got a constant velocity, acceleration is 0, which means that the net force is 0, right? So it means now they are saying they increase the force to 20 Newton. Once the force is increased, it means that velocity will not be constant. Velocity will start to be increasing, which means now we have got an acceleration, right? If we increase the force, obviously, because the force is going this direction, it means that this thing will start to move to the right with some acceleration, right? It will start to accelerate to the right, because now we have got an increased force, right? Okay. So they're saying causing the system to accelerate up the slope. Okay, they just mentioned what I've just mentioned, and then calculate the magnitude of the acceleration of the system if the frictional force acting on the 2 Newton, on the 15 Newton, on the 1.5, on the car is 1.5 Newton, and on the train is 2 Newton. So the free body that we draw there is for the train. So we must understand the free body of the car. That's when everything's going to be easy. All right, that's when everything is going to be easy. So one more thing, guys, that we should understand is, when do we calculate for perpendicular components? The reason we calculate perpendicular components is for us to determine the friction, right? Because our motion is always happening on a horizontal. The reason that we will calculate this one and these two is when we want to talk about what? When we want to talk about friction, right? When we want to talk about friction, that's when we can use that one, because we know that Fk is equals to mu k normal force. So we calculate normal force so that we can have kinetic friction. So since they've already given us kinetic friction, there is no need for us to talk about the perpendicular components now, because we talk about perpendicular components in order for us to understand the normal force, right? So it means that in this case, to calculate this one, we know that on this body here, and one more thing that I will add is that this tension here, T1, T1 is the same both for both car and train. It's just that it is on the different direction. Remember, in this car, this tension here is pulling the car up, but this tension here is pulling the train backwards, right? With the same force. So the tension on the rope is the same, but in different direction. On on a car body is to the right, but on the train the tension is to the left, right? The T1 is to the right on a car, T1 is to the downwards on a train, right? So that is one thing that we should take very important, right? So now let's go and calculate our they said they want what? They said calculate the magnitude of the acceleration. We need acceleration, right? So this kind of question where we've got two body, guys, they are very common, right? They are very common. And what you should know there is that they can ask you to calculate tension or acceleration, but we use simultaneous, we'll find both, right? We use simultaneous equation, we'll find both. Why would we use simultaneous equation? Because we have got this one here, T2, we know it, right? But we don't know the tension here, and we don't know the acceleration. If we know the tension or the acceleration, then the other one will be easy to calculate. But we will have two unknowns. We don't have acceleration, we don't have T2. So it means that we don't have acceleration, we don't have T1, sorry, not T2. So it means that we are going to solve them simultaneously, right? So now let's go to our 2.3. So 2.3, the first thing that I know from this body, like I told you, T2 here have got components. So T2, because it's on the inclined here with a 10 degrees angle, right? So it means that the horizontal component is what? Is the adjacent, because here we have a 90 and opposite is y and the horizontal is x. So it means that it's our adjacent, and for adjacent we use a cos, right? So it means that T2 horizontal, or we can say x, we can say horizontal, or we can say x will be is 10, right? So it's going to be adjacent, so it's going to be cos of 10, and then is what they said is 20 newtons, so it's 20 cos of 10. So can someone quickly give me the answer of 20 cos of 10? Yes, every time you attend a math class, you should make sure that you have got your calculator and the book
19,70.
next to you is 19,70 newtons. Then the direction is, the direction is up the incline, right? Up the incline.
Okay.
So that is the horizontal component, right? That is the horizontal component. That is our T parallel, T2 parallel, right? It's our T2 parallel. So you can see that the net force of this body is made of these forces, right? The net force of that body is made of that forces. It is made of T1, F, what do you call this? Fk, and weight parallel, right? So it means that we know that F net equals to ma, right? So F net equals to ma. So what is the acceleration? We don't know the acceleration, right? But we know that the network is made of T2 parallel, and it's made of Fg parallel, and then it is made of Fk, and then it is also made of T1, right? So I'm taking right hand side as positive, right? I'm taking right hand side as positive. So the only positive thing that is going to the right is T2 parallel, which is the T2x. T2x is minus, right? T2x minus, not equals to T2 minus T2 minus T1 minus kinetic friction minus weight parallel, right? Or FG parallel, right? Weight parallel and FG parallel is the same thing. And then equals to MA, the mass is of a train is what? The mass of a toy train of mass 2 kg. So it's going to be 2 multiplied by acceleration, which we don't know, right? So T2x we already calculated is 19,7 minus T1, we don't know it, minus Fk, and then the said kinetic friction that of train is 2 Newton. So kinetic friction of a train is 2 Newton. And then minus Fg parallel, right? Fg parallel is how we calculate Fg parallel. What is it? Fg parallel, here it is. Fg parallel, how do we calculate Fg parallel? There is an equation where we see it. Fg parallel, you use Fg sine of theta, right? Fg parallel, we use sine of theta. Fg perpendicular, we use cos. So you guys already have this thing. So Fg parallel is sine, right? Fg parallel is sine. So it's going to be Fg mg sine of theta, and then the theta now of this one is the inclination. It's no longer this 10, right? This 10 we are out of it, we already use it, right? So it's going to be equals to 2a. So let's just simplify where we can. This one, okay, let's just simplify the last one first and make sure that, okay, so it's going to be, or we can say 19,7 minus 2 is going to be 17,7 minus T1 minus the mass is what? The mass is 2 kg multiplied by gravitational acceleration is 9,8, and then sine of what? Sine of 20 degrees minus 2a, or equals to 2a. So what is 17,7 minus 2 multiplied by 9,8 sine 20? Because this one is a number, so we just punch it in a calculator, it will give us an answer. What is an answer, guy? What is an answer, guy? As I told you, we must all have our calculators with us, right?
6,70.
Did you subtract the 17? Hmm?
Sir, please repeat.
Did you subtract? Did you say 17,7 minus that one, or you just pressed 2 multiplied by 9,8 sine 20?
So I only said 2 multiplied by 9,8 and 20.
Okay, so I've got 17,7 minus T1 minus, you said it's what?
6,70.
6,7 equals to 2a. So here we've got an equation. So this 2 is a number. So 17,6 or 17,7 minus 6,7 is going to be 11, right? So I can take 2a to the left and then T1 to the right, right? So it's going to be 17,7 minus 6,7 is going to be 11. So it's going to be 11 minus 2a equals to T1. I've taken T1 to the other side. So there is the equation, two unknowns, right? Two unknowns. So we cannot solve it. We've got A as unknown. we've got T1 as unknown, right? And then now we can go to the first body. The free body of the first car is going to be what? It's going to be normal force, weight, and then T1, and then Fk. And then remember, this weight will have two components, right? I didn't throw it well here. Weight was supposed to be here, but it have got two components, which is weight perpendicular, and then here we've got weight parallel, right? So this one is made of these three forces, right? So I'm going to mention it is going to be F net equals to MA, F net equals to MA. So what makes the F net there is the tension, weight, weight parallel, and then Fk. All right. So it's going to be, I'm going to take right to the right hand side as positive again, right? So it means that my T1 will be positive minus weight parallel minus Fk equals to Ma. Are we clear? Are we clear here? Guys, today you are not active. What's wrong? Uncle, what's wrong? You understand what we're doing? Reakil, do you understand what we're doing? Yeah?
Yes, sir.
Do you understand what we're doing?
Yes, sir.
Okay, that's good. Okay, so since now we know our T, we need to find our T. We can make T1 subject of the formula, but what is our weight parallel? Remember, parallel is a sign, right? So it's going to be T1 as mg sine of it minus fk of a fk of a car was 1,5. It was given, right? Going to be 1,5, and then equals to the mass of a car 1 kg, because 1a is a, right? And then which means that our T1 minus mass is what? Mass of the car is 1 multiplied by 9,8 sine of 20 degrees minus 1,5 equals to a. So can you give me the answer there? If we multiply this one and then subtract 1,5, just press this in the calculator and give me the answer. So it's going to be what? What is the answer? Negative 9,8 sine 20 minus 1,5. Guys, we cannot spend more time doing calculations. Everyone must have their calculator, right? I'm sure tomorrow everyone will have their own calculator when we move forward, right?
Negative 4,85.
Okay, when we take it to the right, it's going to be positive 4,
85.
4,85. We took it to the right hand side, it became positive, right? So it's going to be T1 is equals to a plus 4,85. So now we've got two equations. This is my equation 1, this is my equation 2. They both say T1 is equals to. So we can equate them because we know that T1 is the same as T1, right? Told you that tension is the same thing, right? T1 is equals to T1. So it means that I'm going to have 11 minus 2a equals to a plus 4,85. So we'll take the a to the other side. So I'm going to have negative 2a minus a equals to 4,85 minus 11. So It's going to be negative 3a equals to 15,85. So we divide by 3, we divide by 3. So which means that our a is going to be what we divide is nope, it's not 15. This one I've made a mistake here, made a terrible mistake there. It's going to be negative something, right? Is 4 minus 11, so it's going to be what? It's going to be negative what? It's negative 6, comma 15.
15.
Yes, and then we divide by negative 3 both sides. It becomes negative 2, comma 05. Becomes negative 2, comma 05. I'm sure I am correct because I don't have a calculator here. Negative 2, comma 05. What? Because its acceleration is meters per second squared. So the wanted acceleration, we are done. We have our 5 marks there. All right. We have got our 5 marks there. And let's look at the last question and go to the next one. They're saying halfway up the slope, the string T1 breaks and the car rolls down the slope. Does the frictional force of the train increase, decrease, or remain the same while it's still moving up the slope? Explain the answer. So remember friction. What happens? What are the things that affect friction? The things that affect friction is the normal force and the mu k. The what do you call this? Is the normal force. Normal force is only affected by weight, right? Because normal force, you can see that normal force will be affected by weight and the applied force only, right? So whether we don't have a force behind doesn't affect the normal force. And then what other thing that affects the normal force is the mu k. What gives the mu k is the surface, right? The surface of the bottom of the train and the ground. So those two things are not affected by anything about the information that we're given here. So it will remain the same, right? It will remain the same because weight is what we call kinetic friction is only affected by the path taken, right? You know the definition talks of kinetic friction. It depends on the path taken, right? It depends on the path taken. So because the path didn't change, whether the car's still there or not, the path is still the same. So the kinetic friction will be the same, right? So we are done with this question. Let's go to the next one quickly. I gave you 4 questions, right? I gave you 4 questions, and then if we don't finish them, then I will just make videos and upload them, all right? Just make videos and upload them, okay? A block with a mass of 4 kg is held at rest on a horizontal. The block is connected by a light inextensible string with which passes over a light frictionless pulley to another block of mass 2 kg. The 2 kg block hangs vertically as shown in the diagram below. So there we are. So this one, before we start, I know that this body here is easy to calculate my thing. Only two forces will be there. It's going to be the tension and the weight. And if it's not moving, they are balanced, they are equal. Tension is equals to weight. But if it starts to move, then tension and weight will not be the same, depending on the direction it is moving, right? Depending on the direction it is moving, which one will be bigger. But if the body is moving, then tension will not be equals to weight. But if it's moving at a constant velocity, remember acceleration is 0. If acceleration is 0, then tension and weight will be equal. But if it starts to accelerate, whether up or down, the tension will not be equal to weight. All right. Okay. Now they are saying okay, this told us everything about they said light frictionless pulley, but the table, did they say rest on a rough horizontal table? Yes, the table is rough and then it is resting. Once it is resting, guys, it means that we don't have any movement, right? They're saying the 4 kg block is now released. Okay, they were held here, the 4 kg was held, and then now the 4 kg is released and the system of masses moves to the right. it was from rest and it starts to move to the right. So it means that it is accelerating to the right, because if there was no acceleration, it wouldn't start to move, right? So because it's starting to move, it means that it is accelerating to the right, okay? And then they're saying the coefficient of kinetic friction between the 4 kg block and the surface of the table is 0.25. 0.2 is the mu k. So once they give me mu k, I know they're going to ask me to calculate normal force, and then which means that I have my frictional force, right? They might ask me to calculate normal force or frictional force at once, okay? And they say ignore the effect of air friction. State Newton's second law of motion. You're going to do that. And then now they are saying draw a free body diagram showing all the forces acting on a 4 kg block. Before motion, guys, this is where physics becomes very nice, right? Just a 4 marks out of this question. It's already 6 marks. Nothing, you have never done any calculation. We say physics is all about calculations, but look at the 30% of this question, because first 6 marks is 33%. The first 33%, no calculation there, just something that we all supposed to know, or we all know. In fact, there is no one who doesn't know how to state Newton's laws of motion, all of them. And then drawing a free body diagram, no one is supposed to not know, right? We are all supposed to know that, okay? Second law of motion in words. So say Newton's second law of motion in words, you're going to say that, but I'm going to start by drawing a free body diagram of a 4 kg block. So the 4 kg block is on horizontal. Start to the other direction. But friction, this is very important, right? Because they said draw a free body diagram of a kg block. Before motion, the body was not moving. When the body is not moving, we do not kinetic friction, right? We do not have kinetic friction for something that is not moving. We have got static friction. We do not have kinetic friction, right? We have static friction. Out clear? The body is not moving, it's static. So I've got static frictional force instead of kinetic frictional force. So there we are, right? There we are. So now they are saying calculate the magnitude of them. They're saying frictional force acting on 4 kg block. Frictional force acting on a 4 kg block. So how do we calculate frictional force acting on a 4 kg block? So frictional force, remember how do we calculate frictional force? I told you once they give me static friction, I knew they were going to ask me about frictional force. Or Fk is equals to mu k force, because when they to move, just that before the motion, right? Right, and then coefficient of kinetic means that we need a normal force, right? And then on this body, I've got only these two components there, right? I've got normal force and weight, right? So I will start by thinking, okay, F net is equals to MA, right? And is our body moving up or down? Our body is neither moving up or down, so which means that acceleration is 0. But F net is made of normal force and weight to the opposite direction. So normal force is equals to weight. So I know this one. So now I can just, guys, this is very important, right? I usually know, let me just do it like this. I usually calculate them differently, because if I say normal force is equals to weight, you guys will always make it like that every day, and then you end up lying to me and say, but say you said normal force and weight is equal. It is not always equal, right? So I know first and then go and bring it there, because it is not always equal, right? Normal force is not always equal. Not necessary,
So you're breaking.
right? So our force is going to be here is equal. I can see my Wi-Fi here. I've got one back. So let me just go and fetch this other cell phone. try to use it. Let me just go. Okay, is it better now? Is it better now?
Yes, sir.
Okay. I don't know what went wrong, but I don't know what went wrong, but I had to move to another room. Maybe here it will be better. Hopefully, there's no TV on. Couldn't disturb it. I could find network in the Okay. So it means that here we are going to use what? We know that weight is equal to normal force because there was no other force, right? There was no other force on a vertical component. That is why they are equal, right? So, which means here that weight is going to be mg. So what is mg? Our mass is what? Our mass is 4 kg. G is 9,8. So this one is going to give us 39,2, if I'm not mistaken, right? Is it 39,2? Yes, I think it's 39,2. Is it correct? Is it correct?
Yes, sir.
Okay, thank you. So, sorry, our mu k is what? Our mu k is 0,25, and our normal force is 39,2. So it means that when we multiply the 2 is going to be what? When we multiply the 2 is going to be 9,8 newtons. I think so, yes. It's going to be 9,8 newtons. So that is our kinetic friction. Are we clear there?
Yes, sir.
Okay, let's go to this question now. Okay, this one I've got 7 marks. So it means that we're gonna work here. We're going to work here. Okay. I think I'm going to apply motion. Okay, let me just look at this. Okay, now they are saying calculate the speed which the 2 kg block mass strikes the ground. The speed which the 2 kg mass strikes the ground, right? Okay, so it means that I'm going to find the acceleration, right? I'm going to find the acceleration in which this body is coming down, and then I know that this acceleration is going to be traveled for 1 meter, right? This acceleration is going to be traveled for 1 meter. So I know that acceleration is what? Meter per second per second. Okay, it won't work that one. So I'm going to use a what do you call this? Equations of motion, right? Finding the acceleration here is something that we have done in the previous question, right? We use simultaneous, right? So I'm just gonna rub, but if I rub, I hate to rub things. I hate to rub things because, okay, if I rub here, I'll just put the answers on top there so that when I send this document for you to study, you understand what happened there, all right? Okay, so let me just, in fact, I'm going to share the video, right? We've calculated that Fk is 4 Newton, right? We've calculated that Fk is 9,8 Newton. We've calculated that Fk is 9,8 Newton. Remember, I made a mistake there. It must have a direction. Yo, guys, all here, everything must have a direction. This one was supposed to be up the incline, right? Up the incline. That is very important, right? Okay. So this one is to the left, right? The kinetic friction is to the left. Okay, so this one was 2.3.1. So now let's go to 2.3.3. So 2.3.2, you saw 2.3.2. 2.3.2, they want us to find the speed. So I told you I can find acceleration. So I know that from the other body, the body here is going to be weight and normal force, and tension only. Sorry, it doesn't have tension. Normal force is weight and tension. And then for 4 kg block, remember, it's normal force, weight, and then tension, and then Fk, right? So those are the only forces. So now we've got Fk. Obviously, we're going to consider horizontal component on this one and vertical components on this one. So on this one, tension, I will take right hand side as positive for this one. So it's going to be tension minus Fk equals to Ma. So what gives MKMA? So first of all, just write F net, right? Just start by writing F net equals to MA, just for in case if you make a mistake of substituting the forces here, at least the 1 mark of what? The 1 mark of formula, you have it, right? Make sure that you don't lose that 1 mark, right? Make sure that you don't lose that 1 mark for F net equals to MA, all right? Okay, so it's tension minus Fk equals to what is going on now? Okay, is tension minus Ma equals to, is tension minus Fk equals to Ma. So tension is what? Tension is the one that we don't know, minus Fk. We've calculated the kinetic friction and we found 9,8, and then minus equals to, sorry, mass of the body is 4 kg, acceleration we also do not know. So tension is equals to 4a plus 9,8, right? So now let's go to this body. This body, it is made of tension and weight only, right? It is made of tension and weight only. So again, I'll start by saying F net equals Ma, right? So it is made of tension is up and then weight is down, and then we are moving down. So I will take tension as negative and then weight as positive because my things are moving downward. So equals to Ma. So tension, we have already calculated it. We know that tension is 9,8. So it's going to be negative 9,8. Nope. What did I do? Oh, that is not tension, right? That is not tension. Tension, we don't know it. I don't know what am I saying here. Tension, we don't know it. We don't know the magnitude of the tension, right? We don't know the magnitude of our tension. So it means that it will remain as unknown, right? It will remain as unknown. So negative T plus weight. Weight is made of mass multiplied by gravitational acceleration. So it's mg equals to, the mass is 2 kg multiplied by A. So it's going to be tension, negative tension is equals to 2A, and then mass multiplied by gravitational acceleration is what? Is 2 multiplied by 9,8. So it's going to be minus this side, right? And then if you want to change our things to be positive, we can change this T. Remember, it needs to be T. So we can put T to the other side and take everything to the left. So it's going to be 2 multiplied by 9,8 is 19, what? It's 19,6, right? So I'm going to have 19,6 as positive, 19,6 as positive, 19,6 as positive, and then 2A will be negative, minus 2A equals to the tension. Tension becomes positive, right? So for us to calculate tension, acceleration again, we equate the two equations. So this one is equation 1, this one is equation 2. So we know that T is equals to T, and then it means that 19,6 minus 2A equals to 4A plus 9,8, right? So it means that the 2A can go to the right, so it's going to be 19,6 minus what? 19,6 minus 9,8 is equals to 4A plus 2A. So it's going to be this and this, so it's going to be 9,8 equals to 6A, right? And then we divide by 6 both sides. We divide by 6. Our A becomes what? What is our acceleration?
1,63.
1,63 meters per second squared. So that is our acceleration. Distance, we need final velocity, all right? And the initial, remember, we started at 0. So we've got initial velocity because they started at rest, initial velocity of 0, and then we need final velocity, and then we've got the acceleration of 1,63, and then what else? We've got delta y of 1 meter. So which formula are we going to use? We're going to use the equation of the formulas of motion, right? The formulas of motion. So which one are we going to use here? That have got delta y. It's going to be delta y equals to what? Should I Google one? Okay, let me search for one here. Any grade 12 physical science paper will do. Any grade 12 physical science paper will do, right? Okay, let me just use this NCS paper 1, right? Paper 1 English. I'm just looking for equations of motion. As I'm no longer a student, there's no need for me to know all these formulas, right? Every time I go, I'm going to teach kids, and then I am allowed to go with my formula sheet. So unlike you, where if I'm giving you something, I will say, don't bring a formula sheet so that you will know these formulas, right? Okay, so I can use this one, the anything that doesn't have delta t. So which means that is this one, vf squared is equals to vi squared 2a delta x. So it's vf squared equals to vi squared. Is it minus or a plus? It's a plus 2a delta y plus 2a delta y, right? So I need vf obviously. So initial velocity is 0 plus 2. A is what? Our acceleration is 1,63. And then delta y is what? So delta y is going to be 1 meter, right? Delta y is 1 meter. So it means that the answer is going to be Vf is equals to the square root of what is 2 multiplied by 1,63 minus multiplied by 1. Is it 3,26? Yes, it's going to be 3,26, I think. So what is the square root of 3,26? What is the square root of 3,26?
1,81.
1,8. Oh, sorry. 1,81. Where were we? Okay. 1,81 meters per second. So downwards, right? Down or right. If you say down or right, it depends on the body that you're talking about. Or they say the speed of 2 kg mass when it hits the ground, so it's going to be downward, right? The speed of the 2 kg block is downward. So there is the answer, right? There is the answer. So now let's go to this one. This one, they are saying block M1 of mass 8 kg placed at point X is connected by okay, did you all understand this question? I think I skipped one. Okay, they're saying explain why the motion of the 2 kg block cannot be categorized as free fall motion. Cannot be categorized as free fall motion because there is tension. Tension is what? It's a non-consecutive force. There is external force. So that is why the acceleration is not 9,8. So that is the reason why it cannot be categorized as free fall motion. Tension is a non-consecutive force. Something that has got a non-consecutive force, it is not regarded as a free-falling object, right? It is not regarded as a free-falling object. So let's quickly go to this one. This one, they're saying block M1 of mass 8 kg placed at point X is connected to block M2. Okay, so there it is, M1 and M2, point X. Okay, point X, the block was coming from point X, connected to block M2 by a light inextensible string passing over a frictionless pulley. So there is our frictionless pulley. Block M1 is on a plane inclined. M1 is on the inclined here, and then at an angle of 30 degrees. So here is our 30 degrees at a horizontal, and experiences a frictional force between point X and Z. So the only place where it experiences frictional force is from X to Z. After Y, we don't know, right? After Y, we don't know. So it's from X to Y. After Y, we don't know. They said only, in fact. So it means that after Y, maybe there is no friction. Okay, block M2 has an unknown mass and moves vertically downwards as shown in the diagram. So we don't have the mass here. Okay, now they're saying block M1 is released at point X. Block M1 is released at point X and move at a constant velocity to point Y. So from X to Y, it moves at a constant velocity. So if it moves at a constant velocity, what is going to be the acceleration? It means that the acceleration is 0, right? Constant velocity, it means that acceleration is 0. So the thing on point Y, block M1 is released from is released at point X and moves at a constant velocity to point Y. The coefficient of kinetic friction acting on the 8 kg block between X and Y is 0,2. State the Newton's law of motion. State the first Newton law of motion in words. I'm not going to do that. And they're saying consider the motion of block M1 between X and Y. M1 between X and Y. So they're saying draw a labeled free body diagram indicating all the forces acting on M1. So M1 will have a normal force perpendicular to the incline, normal force, and then weight, and then weight or Fg, and then tension up the inclined, and then kinetic friction down the inclined. So that is why it have got 4 marks. It is those 4 forces, right? And then remember, our only problem here is going to be this one. This one we cannot deal with it in that manner because it is in 2 components. It has to be vertical and horizontal component, right? It has to be vertical and horizontal component. So the other free body that we could have used was going to be tension this direction, normal force this direction, and then Fg perpendicular this direction, and then Fg parallel this direction, and then what? Fg parallel this direction, and then Fk also that direction, right? So those are the only components that were going to be there, right? Those are the vertical and horizontal component that we're going to use for calculations, right? Okay, so now let's go to calculate the magnitude of the frictional force acting on M1. So kinetic friction, remember, here again, we don't have any other force. So we don't have any other component on a vertical. So normal force here is going to be mg perpendicular or Fg perpendicular, right? Fg perpendicular will be our normal force, right? Because we don't have any other force. But usually I like to calculate separately and bring it to my equation because I know that to calculate Fk, it's going to be what? It's going to be Fk equals to mu k normal force, right? And then I would like to calculate my normal force separately, knowing that my normal force, the F net is ma. So the body is not moving up or down, so it's going to be 0 here. Sorry, it's going to be 0 there. Oh, sorry, I've went to another topic. It's going to be 0 there. And then F net is made of what? F net is made of normal force and weight, right? It's made of normal force and Fg parallel, normal force, and then minus Fg perpendicular, right? So for Fg perpendicular, guys, we know that for Fg parallel, we use sine. So for perpendicular, it's different. We use a cos, right? So it's going to be normal force is equals to Fg, which is mg, cos of sine. It's cos, right? Yes. I usually make a mistake out of this. I don't want that mistake, right? I don't want that mistake. So this is the one for Fg perpendicular is a cos. Fg perpendicular is a cos, yes, cos of theta. So the normal force is going to be mass, which is what? Mass of the body is 8 kg multiplied by 9,8 multiplied by cos of what? Cos of 30. So what is the answer? Is it 39,6? It's 39,6. Not cos of 30 is not half. I thought maybe sin of 30, right? cos of 30, won't be able to say it because it's irrational. What is the answer? 8 multiplied by 9, 8, sine of theta, cos of 30.
67,90.
67,90. Thank you very much. That is our normal force. So we know that Fk is equals to mu k. Mu k is going to be what? Mu k is going to be 0,2. And then the normal force is going to be 67,9. So what is the answer there? The 13,58.
Yes, sir.
Okay, thank you very much. So it's 13,58. So there is our answer. Right, there is our answer. So that is our kinetic friction, and then we got our 3 marks. And then now they are saying calculate the mass M2. So they want us to calculate the mass M2. So the body was not accelerating because the body was moving on a constant velocity, at a constant velocity, right? So now we know that, okay, it means that, okay, what we know first of all, we know that F net equals to MA, right? So what makes the MA of this body is this tension and FG parallel and FK, right? So it's going to be what? It's going to be F net is made of tension. I'm going to take tension as positive minus FK minus FG parallel equals to MA, right? So now let's substitute our things. So tension minus, do we have a tension? We don't have a tension. We have a tension. They said they want what? They said they want the mass M2. Oh, they want the mass M2, not M1. Okay, so we can calculate the tension. Once we calculate the tension, then we'll come to this one because this one is made of only 2 forces, right? Okay, so tension minus kinetic friction, we've calculated it is 13,58. Then minus FG parallel. FG parallel is mg sine of theta equals to ma. So m is mass, which is 8, and then acceleration, because they said constant. Okay, guys, can you still hear me? I've been disconnected. Can you still hear me? Bali?
Yes, sir.
Okay. Was I disconnected for a longer time?
Not that long.
Okay. So I'm sorry, right? I was explaining that we can when I started writing this formula, was I still connected?
Yes, sir.
Okay, it's fine. So I already explained F net is equals to MA. So F net is made of tension, FK, FG parallel, and MA. So we know that now we can calculate our tension because we know that acceleration is 0 because they said the body is moving at a constant velocity. And then FK, we already calculated, it is 13,58. So it means that we are going to use those answers, right? And then equals to, and then MA 8 multiplied by 0 is going to be 0. It means that we are going to punch this into the calculator and get me the answer. So tension is equals to negative 13,58 minus 8 multiplied by 9,8 sine 30. What is the answer? What is the answer?
Negative 52,78.
52,78 newtons. So we took it to the
Yes,
right
sir.
because we knew that it was supposed to go to the right. Okay. So now we go to the final answer. We take it to the right because we know that on the right is is a 0 and then numbers to the right and then t to the left. Okay, so the last one is going to be about this body. This body, free body, let me show you the free body. It's just a tension to this direction. It's just a weight to this direction. And they say it is moving at a constant velocity. The whole system is moving at a constant velocity. It means that the acceleration is 0, right? So we'll start by writing our F net equals ma. So what makes the F net is going to be tension minus weight equals to ma. So ma, our acceleration is what? Our acceleration is 0, right? So it's going to be let me just write ma is fine. So tension, it is made minus mg equals to ma. So now it's going to be tension minus mg. Mg is going to be the mass, which is m2, the mass that we don't know, right? Multiplied by the gravitational acceleration, which is 9,8, equals to the mass, which is m2, we don't know, multiplied by 0. So m2 multiplied by 0 will be 0, which means that our tension, we already calculated it, is 52,78. So it's going to be 52,78 minus 9,2 multiplied by m2 is going to be 9,8 m2 equals to 0. So it's going to be 52,78 equals to 9,8 m2. So we'll divide both sides by 9,8 by 9,8. So 9,8 and 9,8 will go home. So our m2 will be what? What is 52,78 divided by 9,8?
5,4. No, 5,39.
5,39 newtons, right? 5,39 newtons. 5,39 newtons. 5,39 newtons. So I'm going to end it here, guys. Okay, let me just answer that last question. So here we are done with this question, right? We find our M2. So let's look at the last question. They're saying the 8 kg block continues to move past point Y and up the incline. How will the magnitude of the acceleration be affected? Right, increase, decrease, or remain the same, and give reasons for your answer. So once this body starts to move from this point and start to move here, in this place here, we don't have what do we call this? We don't have friction. So when we don't have friction, what will happen? Oh, when we don't have friction on this, or we don't have friction on this portion. So when we don't have friction, it means that our acceleration will increase up the incline, right? Because there's nothing more that is keeping the system backwards. So the acceleration is going to increase because point A and from after point Y, we don't have friction, right? That is the only reason we don't have friction. Obviously, the body will accelerate. So let's just end our class here. We'll see each other tomorrow. These questions here, if you've got problem, just okay, it's the last question, right? It's the only one question that we didn't do. If you've got a problem with this question, just ask me. I will assist you, right? I will assist you. It was just only one calculation, in fact, but this one here, let me just assist you with this one. Draw a free body diagram of a 9 kg block. The free body of this one, remember, it was supposed to be like this. So this force is going this direction. It means that we write it in this other direction, right? We don't write our vector towards the body. We write it away. So this one, our F will be somewhere here, which means that our weight will be somewhere here, and our normal force will be there. And then our FK be on the other direction. That is going to be our FK. And then, which means that our tension will also be on this other direction. So those are the 5 forces that they were looking for when they said these 5 marks, right? So you can see that out of 12, 7 marks, already more than half of this question, we do not have any calculation. So when you say physics is all about calculation, we are wrong. So physics, whether we understand maths or not, physics, there's no way we can fail physics. We have to pass physics because of all these things. Guys, in maths, there is no easy marks. But look at physics, free body diagram, definition, you get a mark for equation. This kind of equation, guys, is Newton law. If they say there is a in any equation, just know that F net equals to MA will have a mark. F net equals to MA will have a mark. So once you have to calculate something, you don't know where to go, and it's talking about Newton, just say F net equals to MA. That's Newton's slogan. F net equals to MA. That's Newton's slogan. So let's see each other tomorrow, guys. Hope you enjoy. Just go and practice if you've got any other subject that you are writing, and then don't forget to ask me questions if you've got questions, right? So tomorrow's session I won't cover grade 11 I will have them separately, because tomorrow I want us to look at vertical projectile, and then I've given you some questions there on vertical projectile, right? So but I think I should prioritize this one of the graphs also. If you understand graphs, it will be easier for us to understand the motion, right? To understand the motions. So hopefully we'll manage to do all the questions tomorrow at 8. But for now, let's call it a day sharp.